Unit 1 Construction Principles. Week 23A. Natural Daylighting. The aims of this session are as follows. 1. Identify problems with trying to work out the amount of daylight in a building. 2. Identify the two forms of measuring daylight outside. 3. Identify what is daylight factor and how to calculate it for a room. 4. Identify the three main components that make up daylight factor. Daylight in a building. Identify the problems with trying to work out the amount of daylight in a building. What factors will affect the amount of daylight we have in a room? Daylight, or natural light, is provided directly by the sunlight and/or the sky. Sunlight, which is direct light from the sun, is so variable that it is not of much use in lighting design. Illuminance from the sky is also variable. It varies during the day and through the year. In countries where the climate is not reliable, for example the UK, an overcast sky is considered to be the main source of daylight. It also represents the worst type of daylight. Therefore the sun is not a consistent strength and therefore it is hard to measure sun strength and light. We therefore have two ways to measure it: a uniform sky standard and a CIE standard sky, USS. Uniform sky. The uniform sky is an overcast sky considered to have the same luminance for the entire hemispherical sky. The universal system was set up to standardize sun conditions, and works on the principle of sky is taken as an overcast day with same level of luminance in every direction of view. Viewed from an unobstructed point on the ground, light comes from every direction in the calculation. Your hemisphere around this point, 5000 lux, is the standardized light level at an unobstructed point on the ground. CIE standard overcast sky. In the CIE Commission Internationale de l'Éclairage sky, the luminance varies with the angle above the horizon. This has close resemblance to the luminance distribution of a real overcast sky, luminance at an angle from the horizon, as shown in figure, where L is the luminance at the zenith. The luminance at the zenith is 3 times the luminance at the horizon. Daylight enters the interior of a building through windows or roof lights. The illuminance due to daylight inside a building will reduce rapidly as the distance from the windows and skylights increases. The amount of daylight that is able to penetrate to a point in a building is expressed as the daylight factor. The daylight factor is defined as the ratio of the natural illuminance at a particular point on a horizontal plane to the simultaneously occurring external illuminance of the unobstructed overcast sky. In the UK, the standard sky is assumed to give at least 5000 lux of illuminance on the ground. Definition of daylight factors. Daylight factor is the ratio between the actual luminance at a point inside a room and the luminance possible from an unobstructed hemisphere of the same sky. The unit of a daylight factor as a percentage of the outside light. Daylight factor calculation. The formula shown gives you the method of calculating the daylight factor. Outside light levels. When calculating the daylight factor, we use the assumed light levels indicated on the table. Typical daylight factors. The table shows the minimum daylight factors for a room. The daylight factor is defined as the ratio of the natural illuminance at a particular point on a horizontal plane to the simultaneously occurring external illuminance of the unobstructed overcast sky. In the UK, the standard sky is assumed to give at least 5000 lux of illuminance on the ground. Once we have taken daylight readings across multiple points in a room, we are able to plot the daylight factor results on a plan of the room, and create contours. You will see that the daylight factor near the windows is high, but as we get further away from the windows on the far side of the room, the daylight factor reduces. Daylight factor example calculation. If there were 20,000 lux available outdoors and 400 lux available on top of a desk in an office, then the daylight factor for that point would be as indicated. Daylight factor example 2 calculation. Calculate the illuminance at a point in a building if a daylight factor of 3% is required. Assume that the external illuminance due to an unobstructed standard sky is 5000 lux. To solve this problem, you need to first transpose the formula to make internal illuminance the subject. The answer is D.F multiplied by E.O, divided by a 100. Therefore it is 3 multiplied by 5000 lux. divided by a 100, which equals 150 lux. In class, use a light meter to work out the daylight factors for a given point in a room. Assume the external daylight of 5000 lux. Daylight factor components. When we work out the daylight for a particular point in a room, we work it out using three principles. The daylight reaching any point inside a room is made up of three components. A. Sky component, SC. Light received directly from the sky through windows. Direct light is not considered for calculating the sky component. B. Externally reflected component, ERC. Light received directly from external reflecting surfaces like buildings and vegetation. C. Internally reflected component, IRC. Light received after multiple reflections off floor, walls and ceiling. The daylight factor is the sum of the three components. D.F equal S.C plus ERC plus IRC. The sky component and the internally reflected component are the more important components. The externally reflected component makes a very small contribution to the daylight factor. The sky component and the internally reflected component are the more important components. The externally reflected component makes a very small contribution to the daylight factor. Inside lit rooms, the maximum D.F is near the windows, and it is mainly due to the sky component. Both the sky component and the externally reflected component decrease as the distance from a window increases. The internally reflected component, however, remains uniform in the room interior.